Lightning Legends, it's Prof. Gene. In this lesson, we are going to show that you are electric, or more accurately, that you are conductive, and your jolting presence can be identified by the capacitive touch sensors on CircuitPlayground Boards. And this is super simple to achieve using CircuitPython. We'll show you how to detect touch that acts like a standard button press, and we'll also show how to debounce touch to detect only one touch at a time. Then we'll end with a drum machine challenge, and we'll show that solution in the next lesson. So let's spark up that big learning. The Express and Bluefruit boards have 7 capacitive touch pads. They're labeled A1 through A6 plus TX, also labeled A7 on the Express, and they're super easy to set up and use. Capacitance is the ability to store a charge, and water has a higher capacitance than air. And to borrow a phrase from Star Trek, you, human, are a bag of mostly water.
Bags of mostly water. An accurate description of humans, sir. You are over 90% water surrounded by a flexible container.
So when you touch or even come close to a capacitive touch sensor, your capacitance, the ability to store charge, typically lowers the voltage. So that's how capacitive touch detection works. Now you don't need to know how this works for maker projects, you just need to know that it works. Now capacitive touch sensors don't just sense human touch, they can detect any change in capacitance. They can sense a pet's touch, and the electricity in the touch can be passed from whomever or whatever is touching the pad through any conductive material. Here are just a few examples. Conductive clay, metallic bows and ribbons, Velcro-style hook and loop tape, conductive elastic, conductive thread and fabric, copper tape, and conductive paint. And in fact, detection can be also transmitted through organic material. So if you clip a pad to a plant leaf, we can detect when that plant has been touched.
I am Groot.
Now, Python doesn't normally have routines for touch detection, so we're going to import a library to work with touch, and this library is called touch.io. And for our first foray into touch, we'll create 3 objects that can detect touch. And it's even easier than setting up a button. It's just a one-liner. We'll use the touch.io's touch-in class for that, and we'll just pass in the name of the pad that we want to use. In this case, board.a1, board.a2, and board.a3. After that, touchpads can work like standard buttons, and like a standard button, a standard touchpad set up like this will fire as long as a finger's down on it. But later in the lesson, I'll show you how to set up debounced buttons that only detect one touch at a time. But why don't we start with this? Like standard buttons, we'll check to see if the dot value property of a touchpad is true. That means it's being touched. Now for starters, let's write some simple code. If we detect a touch on A1, we'll flash red, we'll play the cowbell, then we'll turn the lights off. If we detect a touch on A2, we'll flash orange, we'll play BD Zome. And if we detect a touch on A3, we'll flash yellow, and we'll play the electric high snare. So let's code this up. And now to begin, plug in that CircuitPlayground board, Bluefruit or Express. Start up PyCharm. If you're new here, welcome. You may want to check out the prior lessons in the playlist to see how we got to this point. Also, I'm assuming that your Circuit Playground has the drum sounds folder on it. That's the same folder that we used in our lesson when we learned to play WAV files. If you don't have that folder, you can download it from the Google Drive at bit.ly/circuitpython-school-files, all lowercase. So the last file that we had created was the Who Moved My Stuff alarm, so we'll start out here, and I'll get rid of some of the things that I don't need. I don't need bus I/O anymore, or the LIS3DH. Those were just used to be able to work with the accelerometer, and I'm going to highlight everything from create buttons on down and delete it and start from scratch. Now I do want to import colors, and we're going to use more colors in the next lesson. So why don't we open a browser and head over to bit.ly/circuitpython-colors. This is the Google Doc that I created with the import statement for all of the created colors that exist in the CircuitPython animation library. And I'm going to highlight from through black, copy it, head back to PyCharm, and paste it in just after the import statement. And I'm just going to insert a backslash for the line continuation character. I'll do that just before cyan, and remember it's a backslash, not a forward slash, and press return so that I can list all of my colors on 2 lines. It just makes them easier to see. Now, whenever you work with capacitive touch in CircuitPython, you have to import touch.io. So we'll add that to our import line. That's one word, touch.io. Now down here where we set our path variable, we're no longer going to be working with our alarm folder. We're working with drum sounds. That's one word, and the only capital letter is the first S in sounds. Make sure you got the slash at the end. That's going to separate the folder from the files inside of it. Then let's set up our 3 touchpads. So first we'll call a touchpad touchpad_A1. We'll set this equal to touchio.touchIn. This is a class with a capital T, capital I. And in parentheses, we'll pass in board.A1. And then we'll do the same for touchpad A2 and touchpad A3. Make sure you're passing in board A2 and board A3 for both of those as well. And dang, I'm realizing I deleted the play sound function. I probably shouldn't have done that, but we've entered play sound a number of times, so we can do this pretty quickly. The play sound function is def play underscore sound, passing in parentheses file name, make sure you got the colon at the end, then indented where with open, between parentheses we pass in path plus file name, then comma, between double quotes RB, we're reading the binary file off of the device, and outside of parentheses as wave underscore file colon, so we're creating a variable called wave underscore file that has the raw binary or the raw data that we just read in. Then below this in indented, we create a new variable called wave and set this equal to an object that we'll create from the class wave file, capital W, capital F. And we're going to pass in the wave underscore file variable we created above. Below this at the same level indented, audio.play, passing in wave, will start playing the sound, and then underneath this at the same level we'll say while audio.playing colon, and indented below this will be pass. So every time we call play underscore sound, we're going to play the sound until we're done, then we're going to resume. And I notice PyCharm's showing me a warning in my wave file up here. You can see the closing parentheses in yellow. And if I hover my cursor over, it says parameter buffer unfilled. That's okay. You don't have to worry about it. Then below this, let's create our while capital T true colon infinite loop. And indented below this, we'll say if touchpad underscore A1 dot value colon. So if value is true, then indented below this, we'll say pixels dot fill, passing in red, RED, then play underscore sound, passing in the string drum underscore cowbell dot wave. Then after this is done playing, we'll pixels dot fill, passing in black to turn the lights off. And I'm noticing that the variable pixels is showing up with the red squigglies of anger. Oh, and that's because I didn't define the pixels variable yet. So let's do that up above. I'll do this just above the play sound function, and we'll set up pixels as pixels equals lowercase neopixel, that's the name of the library, dot neopixel with a capital N, capital P, that's the name of the class, passing into the class factory board dot, in all caps neopixel, the location of the neopixels on our board, comma 10 because there are 10 of them. And if we take a look down below, the red squigglies of anger are gone. And as mentioned, by setting the pixel fill to black after this, that turns off all of the lights after the sound is done playing, then I'm going to highlight this if statement and everything that's underneath it, copy it, then below this, outdented to the same level as the if statement, I'll paste those lines again. But this time we'll say if touchpad underscore A2 dot value. We'll change the color to orange, and we'll play sound as BD underscore zome. That's Z-O-M-E, M as in mom. Then I'll outdent below this and paste in those lines again. This is going to be touchpad underscore 3. The color is going to be yellow, and the string for the sound is elec, E-L-E-C, underscore high, H-I, underscore snare. Then open up your terminal, make sure you're in TIO, I'm already there, then save, and why don't you orient your Circuit Playground this way, and let's test this out. A1, A2, A3, and listen, when we touch A2 and A3, if we don't take our finger off quickly enough, it registers multiple presses. That's because these touchpads are not debounced. So why don't we try out debouncing, and we'll check out the difference, although why don't we change the comment up here to read capacitive-touch-circuit playground, and we'll save it with that name to our CircuitPython school folder. Always make sure that you close the outermost tab. And now let's try this with debouncing. And let's change our comment up top to read capacitive-touch-debouncing-circuit playground. And remember, when you want to use debouncing, you've got to import a library. So under the import statement, we'll say from, it's Adafruit underscore debouncer, import capital B button. That's the only class we need. Then down here where we set up our touchpads, now we're going to do it with debouncing. And I'm going to change the name of the touchpads that are initially set up with touchio.touchin to touchpad A1 input, touchpad A2 input, and touchpad A3 input. And I'm going to pass these into the debouncer library's button class. That'll create debounced buttons. So underneath the touchpad A1 input, I'll call my first debounced pad touchpad underscore A1, set this equal to button with a capital B, and between parentheses I'm going to pass in touchpad underscore A1 underscore input, that's the touch in object I created above this, but also make sure you pass in a second parameter, comma, value underscore when underscore pressed, and set this equal to true. If you don't do this, then pressed won't fire when you touch the pad, it will fire when you take your finger off the pad or release it. Then I'll copy this same line, paste it down below twice, change the reference to the input variable to A2 input and A3 input, and the touchpad name to A2 and A3 respectively. Don't at all worry about the yellow warnings that you see up here, that's nothing to worry about. Now in our while true loop, very important to remember, inside that loop we want to make sure that we call update on all 3 of our debounced buttons. If we don't do that, we're not going to record when the button state changes, so our if statements won't work properly. So that's touchpad_1.update, touchpad_2.update, and touchpad_3.update. Those updates are methods, meaning they're functions attached to the object, so make sure that you've got open and close parens after them. Then we don't check the .value parameter for the buttons, we check the .pressed parameter for the buttons. So I'll change value to pressed in the 3 if statements, and that's it. Let's open TO, save, and see how this performs. So I'll touch each pad, and as I keep my finger on it, notice that the sound is only playing once, and those lights are shutting off as soon as that sound is done playing. This is exactly what we wanted. And you can keep tapping away. Each time, again, you touch one of the pads, you'll turn on the light, play a sound, then turn off the light. You can jam out for a bit, but mission accomplished. You have touchpads with debouncing. So close the terminal and save this to your CircuitPython school folder as Capacitive Touch Debouncing Circuit Playground, and close that outermost tab. So, my friend, after this lesson of more big learning, it seems you have the magic touch, because you now know how to use capacitive touch on the CircuitPlayground Express or Bluefruit, and there are times when you want pads to behave like standard buttons and continually fire when a finger is held down. This might be something that you want to do if, for example, you're creating a DJ board and you want to loop through a sound as long as a finger is held down, but there are other times where you might want one touch to correspond as one button press, and if you need that, you can just use debouncing. Just like with standard buttons, we'll use the button class from the Adafruit Debouncer library, but you pass in the touch in object you created as opposed to the digital in out object that you created when you were working with standard buttons. And just like when creating debounced buttons using the built-in buttons on the Circuit Playgrounds, you set the value when pressed to true. And now that you've got this down, let's issue a challenge for you to try, and we'll compare answers in the next lesson. So your challenge is to build the drum machine. Create a list of strings that correspond to all of the sounds in the drum sounds folder on your CircuitPy board. So that list should be named drum samples like you see it here. And these are the names of the various different files. You can copy those directly off of your board if you want to make sure that you make no spelling mistakes. But these are the names. This is the list you should create. Then create 7 touchpads for all the touchpads on your CircuitPlayground board. Board.A1 through board.A6 plus board.tx, and place them in a list named touchpad. Then, when a touchpad in the list has been touched, play the corresponding sound in the list of drum samples. When you're done, save that as drum-machine.py. I've got my CircuitPlayground Bluefruit hooked up to an external speaker. I showed how to do that in a prior lesson, just so that you could hear the sounds a little bit louder. You can use regular touchpads. You don't have to use debounce touchpads, but this is how it should work. And as a bonus, my good friends, if you have alligator clips, and all my students do, you can hook up one end to a pad and push the other end into anything that's conductive. For example, a coin, like this euro for creating euro beats, or various pieces of fruit, and rock out food group style like this. I hope you're feeling good about these skills, Pythonista. See you in the next lesson, where we'll check out the awesomeness that you made.